Let's go ahead and do this. So now I'm recording this onto my hard drive. And Kate Timmerman, our Vice President of Development, is the person who will introduce the speaker and will do the Q&A afterwards. So I will turn the floor over to Kate. Thanks, Kate.
Great. Thanks so much, Patty. Yeah, I'm really excited to introduce Rachel Brandt today. She is a PhD student in biomedical engineering at Illinois Tech, so Illinois Institute of Technology. As we can see, she is going to talk about developing a multivariable artificial pancreas system for people with type 1 diabetes, which actually she received her BS in biomedical engineering from the University of Texas at San Antonio before she moved up to Chicago. So I hope that she is okay with our lovely Illinois weather. And she's been working since 2016 when she moved up here. She's been working on this artificial pancreas. And from what I understand, has worked on a few different aspects of it, including the effects of sleep efficacy and sleep quality. And I'll look forward to hearing about how that relates to the diabetes stuff. And I think at this point, I will transfer it over to Rachel.
Thanks so much. Yeah, so I'll be talking kind of generally about the whole system we're developing at IIT, as well as my work, which is more focused on the sleep side. So just kind of a brief outline. I'm going to go over what type 1 diabetes is, kind of the diagnosis and how the disease starts, the demographics, the current treatments, and then again, generally the whole system that we're developing at IIT, and then all of the work that I've been doing to develop the sleep module that will go into our system once it's complete. So in non-diabetics, your pancreas secretes this hormone that's called insulin, which helps bring all of the glucose from the blood into your cells to be used as energy. But for people with type 1 diabetes, there's this immune response that's triggered that your body essentially destroys the insulin producing cells in your pancreas. And so you no longer have this insulin secretion into the bloodstream, which leads to this buildup of glucose that requires insulin to be injected or pumped, however, into the body by the user to help control these blood glucose levels and bring it back down into the normal healthy range. In the US right now, this figure's a little bit old, so it's a little higher, but there's about 1.25 to about 1.5 million people with type 1 diabetes, and that's about 5% of all people with some sort of diabetes in the country. But the most significant thing is by 2050, so in the next 30 years, we're supposed to see an increase up to almost 5 million people living with type 1 diabetes in the country, with a significant portion of those right now being adults. And then again, the 5 million people will include close to 600,000 youth with type 1 diabetes. So it's not, type 1 is typically seen as kind of a childhood disease, or juvenile diabetes is what it was used to kind of have been known as, but it's more kind of, you can be diagnosed at any age. And so again, one of the main aspects of controlling this disease is monitoring your blood sugar and making sure it's in kind of a proper healthy range. And there's multiple ways of doing that. The most traditional is obviously finger sticks, which most people are familiar with, where you prick your finger, you have a drop of blood, apply it to a test strip, and you get a reading of what your blood sugar is. The next, and some people may have seen commercials for this, it's starting to become more popular, is a flash glucose monitor. And this is a sensor that is inserted under the skin for 14 days at a time. And you have this receiver right here that you scan this white transmitter that sits on the outside of the skin to get a blood glucose reading anytime. So it has essentially eliminated the need for finger sticks. And then finally, there's continuous blood glucose monitors. And like the flash glucose monitor, it's a sensor that sits under the skin and will transmit a blood glucose level every 5 minutes to either your phone or your insulin pump, to where you get an almost continuous reading of what your blood sugar is at all times. And then this bottom one is a newer one that is actually an implantable sensor. So it is implanted under your skin for 90 days at a time. And you attach a transmitter on the outside of the skin that then transmits to your phone. And then you only change it every 90 days, whereas these are every 7 to 10 days. And then the next is insulin. So you need to replace the insulin that your body no longer makes. And one way to do it is through multiple daily injections, where you inject 2 different types of insulin. One is long-acting insulin, which lasts in your body roughly 24 hours, which will help match kind of that glucose production from your liver and keep a constant, steady blood glucose while you're not eating or while you're fasting. And then the other is your rapid-acting insulin for when you need to bring down a high blood glucose level or before you eat, anything to kind of quickly correct your blood sugar. And then the second are insulin pumps. There's 2 types. One is a tubed pump, which you have a cannula that sits on the skin, and you have a reservoir of insulin within the pump. And then the other type is a patch pump. You can kind of see it down here, that just sits on the outside of the skin, and you control it with something that essentially looks like your cell phone. It's a kind of more discreet if you don't want it sitting kind of on your waistband looking more or less like a pager. Some important definitions that'll be used kind of later on is the basal and bolus insulin, where again, like that long-acting insulin I was talking about, the basal insulin is delivered by your pump in hourly rates that are meant to match that glucose production and help keep your blood sugar at a constant level when you're not eating. And then bolus insulin is this larger dose of insulin used at mealtimes or in response to increasing your high blood sugar levels to bring them back down into a normal value. And then within the last 4 or 5 years, the most recent innovation in these insulin pumps is hybrid closed loop. And what that means is the pump starts automatically giving you varied amounts of insulin without you having to tell it to do that. And so how this one works, this pump I'm showing you is from Medtronic, and it was released in roughly 2016, 2017. And this one will increase or decrease that basal insulin that I was talking about based off of your current and predicted blood glucose level. So if your blood sugar level is starting to rise, it'll start to increase your basal rate to help it kind of blunt that response. Or if your blood sugar is starting to drop, it'll start reducing and suspending the basal insulin levels to help prevent low blood sugars. And then this second system came out within the last year. It's a little bit more advanced, and you can see in kind of this description, if you can read it, that it will, depending on what your predicted blood sugar level is, it will either decrease your basal insulin, stop your basal insulin, keep it at your kind of scheduled amount that your doctor has helped you decide what level it should be at, or increase your basal if it starts seeing your blood sugar go up. And then the main difference is that this system will actually start giving you those bolus insulin deliveries, so higher amounts when your blood sugar is starting to go above 180 into kind of the hyperglycemia, high blood sugar ranges. However, these systems are mostly reactive. They're going to react to whatever change in the blood sugar it's seeing. It uses some short-term predictions. It's only using the insulin and blood sugar levels that it's getting from your pump and sensor, and still requires a lot of user input. You still have to input all the meals you're doing. You have to prepare for if you're going to exercise, things like that. And so while these are really great innovations, one of the things we talk about a lot in the lab is that diabetes is a mess. So your meals are going to start increasing your blood sugar. Exercise, depending on the type, the intensity, the duration, how much insulin you have given yourself before. If you ate before, you're going to have varied responses. Stress, again, depending on the type of stress, Your blood sugar will respond in different ways. And then finally, sleep, which is what I'm working on to include into our system. And so at IIT, in the last probably 10 plus years, my advisor has been working with multiple students to kind of develop this multivariable artificial pancreas system. And what it is like those hybrid closed loop systems I was talking about before. It's like that, but fully automated. It's a fully automated insulin delivery system that takes in other signals besides just blood sugar and insulin to help make predictions on what the user's blood sugar will do and help either give them boluses, increase their basal. And so some of the modules that it has are this glucose and activity feedback. So based off of exercise, we have modules for low blood sugar prediction, high blood sugar prediction. It'll suggest certain amounts of carbs people should eat if their blood sugar is starting to drop too low. The sleep module, another one that's listed is we have been able to automatically detect when they've eaten based off of subtle changes in their blood sugar level and start dosing insulin to prevent the spikes in blood sugar from that. And this is just essentially another breakdown of how the system is working. So the whole algorithm that is controlling the insulin pump, so controlling how much insulin we're giving the users, is housed on a smartphone. And that smartphone is taking in the signal from the continuous glucose monitor. So it's taking in all of that, the blood sugar readings. And then also we have a wristband. So we're collecting all of these activity signals, different things we can classify with other algorithms and using those as inputs into our system. So classifying if they're exercising, if they're stressed, classifying their sleep, things like that, that'll help guide these glucose predictions and use those to deliver insulin to the user. And again, this is fully automated. The user doesn't have any input. They don't have to worry about correctly counting their carbs or making sure that they won't drop too low while they're exercising, things like that. And so my main part is developing this sleep module for this system. And so the main objectives for what my module will do is real-time adjustments. So real-time adjustments overnight based off of the sleep stages. If we predict that their blood sugar will rise or drop based off of the kind of sleep architecture, basically. So the makeup of their sleep and things like that. And as well as mitigate kind of the effects of sleep on the daytime control as well. So taking in everything that happened overnight and using those in our daytime predictions for how much insulin they need to be getting. And so kind of a little background on sleep. So when we all sleep, we start awake and then we transition into non-REM sleep. And what non-REM is little eye movement. Your muscles are more relaxed, your heart rate decreases, your breathing rate and your brain activity all start to decrease. And then once you move through the non-REM stages, you move into REM sleep or rapid eye movement, where you have more muscle twitches, increased and varied heart rate and breathing, and increased brain activity. And you cycle through these stages about 3 to 4 times until you eventually wake up again in the morning. And so here's another kind of breakdown of what your sleep looks like overnight. And so you can see how you started in wake and slowly transitioned through the light, which are the green highlighted, and the deep sleep stages. So the light and deep non-REM stages until you eventually go to REM. And you slowly cycle through these until you cycle through the lighter and lighter stages until you wake up again in the morning. And so you can see that the deep sleep is mostly found kind of in the first third of the night. And then REM typically dominates the second half. One of the problems though with these sleep stages and getting as accurate sleep stage information like this is that it's done through what's called polysomnography. And I'm not sure if everyone's familiar with it, but it's a pretty invasive way to measure sleep. So you have multiple electrodes on your head and face, as well as your chest with multiple chest bands. They typically have a sensor on your foot as well to get leg movement. It's a pretty unnatural way to be sleeping. And so one of the main parts for us to be able to use such specific sleep information in our system is we need to find a way to get all of this on the wristband. I'm not going to talk much about it, but essentially we're taking in heart rate, the electrical activity on your skin, the skin or your wrist movements, and your skin temperature from this wristband, and using all of that information to determine what sleep stages you're in real time. And so some of the work that I've done, this was done with non-diabetic men. So they were healthy men, no diabetes. They were excluded if they were. But what we found was that during REM sleep, where you have more of that brain activity, your blood sugar typically decreases during that time. And then during deep sleep, you tend to see rises in blood sugar during deep sleep, and then about in a 10-minute period after they've moved out of that deep sleep as well. And that's typically because in deep sleep, you have a lot of hormones that are being released that tend to bring on some blood sugar increases. And then for a lot of our studies with the type 1 patients and how we're getting all of this sleep information is we're using an at-home sleep monitor. And so we get very similar information where we get their light, deep, and REM sleep stages instead of the more specific, but we're still getting fairly specific sleep information from roughly 23 people right now with type 1 diabetes, and we have around 200 nights of sleep information and corresponding daytime where we have their insulin pump data, their food and activity logs, so we can use all of that information. And from that so far, we found that those with poorer sleep quality overnight tend to have higher variability in their blood sugar, so they have higher standard deviations in their CGM values. So their blood sugar is fluctuating more while they're sleeping, which tends to lead to poor sleep quality. As well, people who have a higher percentage of deep sleep overnight tend to have higher average blood sugars overnight, which falls in line with what we had seen in that study with the healthy men, where your blood sugar tends to rise and keep rising after periods of significant deep sleep. And so this kind of matches along with that, where they have higher averages overnight when they spend more time in deep sleep. And then finally, again, those who spend more time in deep sleep overnight tend to spend less time within the target range of blood glucose levels. And time in range has been defined as the time you spend between 70 and 180 for your blood glucose levels. And then finally, the effects of sleep on daytime glycemic control. We have a lot of information that's unpublished, so it's going to be very general, but a lot of it is subject specific. So we see different effects in each person. But the main overall thing is that the sleep has been plays a role in insulin sensitivity during the day. And what that means is the insulin sensitivity is pretty much how much insulin do you need to take to bring your blood sugar down a specific amount. So if you're really sensitive to insulin that day, you need to take a lot less insulin to bring your blood sugar down than on a day that you're really resistant. And this falls in line with some smaller studies that have been done in both non-diabetics and type 1 diabetics. So on the bottom left, this was a study where they suppressed the deep sleep overnight. So they had people in a lab, and anytime they saw them moving into deep sleep on the polysomnography, they would play an auditory tone that wouldn't wake them up, but it would move them out of deep sleep. And they found that after those nights, the people had a reduction in their insulin sensitivity. So these non-diabetics were more resistant to insulin on nights after they had less deep sleep. And that was found in similar studies with type 1. And then on the right was a study with type 1 diabetics where they reduced their sleep from 8 hours to 4 hours. And so on the night of sleep deprivation, they ended up having a decrease in insulin sensitivity by around 20%. So just a single night of going from 8 hours to 4 hours of sleep made them significantly more resistant to insulin the next day. And again, this was a study that was also done in non-diabetics. So sleep is relatively important to everyone. That they found that both your kind of sleep architecture, which is the sleep stages that you're in, and then your sleep time has kind of effects on your insulin resistance or sensitivity during the day. And so just kind of that was a lot. So kind of a summary of everything that I'm doing is really kind of developing this kind of all-encompassing sleep module for our automated insulin delivery system. And it's something that will be able to predict and mitigate the changes in blood sugar levels overnight in real time, as well as take what we know about their sleep and help our predictions be better during the day for how much insulin they're going to need, because we'll know how much more resistant or sensitive they're going to be this day based off of what their sleep was. And then just kind of a general thank you to ARCS. In the last year, I was able to actually go to some conferences before things shut down. In November, we traveled to Bethesda to present at the Diabetes Technology meeting. And then thankfully, I was still able to go to Madrid in February and present at a conference there. And then was able to still go to a virtual one in June. So that was it.
Nice.
Great. Yeah. Thank you so much.
Thank you.
So I want to like first ask some questions and then open them up to everyone else in the virtual room. I think I have a few different questions. I actually want to start with one. There was a little asterisk in your slide where you were showing some of the data and it looked like all the data was from men.
Yes.
And I'm wondering, I know that there's a big, there are a lot of discussions about, sex differences in research and whatnot. And so I'm wondering, that data was background data. So I'm wondering, what your thoughts are about that. And then with your study, were you only looking at men? And of course, the question is why, what's the difference with women, that kind of stuff.
Yeah, so it was way over here.
It was way at the beginning.
Yeah. So this one was in men because they wanted to, so one of the main issues is that women secrete different hormones than men, and the hormones in women affect blood sugar differently. And so in a lot of sleep studies, they either only do them in men when they're looking at hormones, or they have to be very specific about what phase of the menstrual cycle women are in to be included in the studies. So that's one of the reasons why some of them have only men, is so they don't have to worry about that. But our study breakdown is almost 50-50, men and women. And so we take so when doing some of these analysis, we take into consideration gender, and there are some significance in the differences in gender as well, which is to be expected because we know there is gender differences in sleep and in kind of the circulating hormones, and all of those hormones also affect blood sugar levels.
Well, thanks. And so when you are including women in your study, do you generally try to make sure that they're at the same time in their cycle, or are you willing to deal with that variability?
We're willing to deal with that variability. A lot of our studies are we just collect information from people in their daily lives. We don't want them to change anything. We have them make note if they are in specific phases, but we just kind of take it as it is, let them control it. And that's cool.
Great. Thank you very much. And then, so, it sounds like the lab that, it sounds like your lab, studies has a whole bunch of different projects, many of them focused on this artificial pancreas. How do you guys as a group kind of get together and, piece your different projects together?
So our lab is a combination of different types of engineering. So we have electrical engineering students, we have chemical engineering students, and biomedical engineering students. And each project that someone has is really related to their strengths. So a lot of the chemical engineering students, even though they're not used to some of the kind of biological parts of it, they have a strong understanding and knowledge of control systems. So they can take in the variables that some of the electrical and biomedical engineering students are finding in these relationships and kind of use them in their control systems, because they're the ones building that base of the AP system, and use those as the inputs to control the blood sugar. And so we all have kind of these different parts with strengths coming from different educational backgrounds to come together and kind of piece the whole algorithm together.
Cool.
If that answers the question.
Yeah, that definitely did. So when you first started in the lab, that was 2016. Did you, was there a specific kind of angle that you were most interested in that has resulted in this project? Like, have you always been interested in diabetes or insulin or, kind of artificial devices?
So I've had type 1 diabetes for the last 16 years. So when looking for a project for my PhD, I knew I needed something that I had a bigger connection to stay motivated through all of it. So when looking for a school and a PhD project, I came across IIT and their kind of diabetes center, and this project specifically. So that's how I kind of got into this area.
That's very cool. So you weren't working on diabetes research like when you were an undergrad or anything like that?
Mm-mm.
Cool. Well, that's very cool that you found the school and the project and were willing to come here to launch your career. So I have a few kind of broader questions, but I think I first want to open it up before I get too far away from the science to see if other people have questions. It looks like Jerry has a question.
Well, this is just sort of a basic question, but Rachel, you say you've had it for 16 years. What causes diabetes? And I've heard some people say that you can inherit it. I mean, I had a grandfather that had it, but I don't have it, fortunately. But is it diet? Is it lack of exercise, or what causes it? And once you have it, can you get rid of it?
So a lot of what you were mentioning is more on the type 2 diabetes side, where type 2 is more, genetics plays a role in all types of diabetes. But for type 1, there's no reversing it, because once your insulin producing cells have been killed off, they can't come back. So you no longer produce insulin. So you always have to keep replacing that. I have no family history of diabetes, but I have a family history of autoimmune diseases. And so that might be where that comes from. Some of it is genetic. A lot of people, I know someone who has a parent with type 1 and she has type 1 now. And a lot of it is either some environmental factor, like a lot of people think some viruses will trigger this immune response. There's something that kind of triggers this underlying issue that's there for your body to then attack those insulin producing cells. And so that's one of the main kind of hurdles in kind of the cure aspect, is that the cause is still relatively unknown, other than that it's just an immune response. So does that help?
Thank you.
An immune response caused by a virus?
So some people have gotten the flu, and just that change has triggered their body to then attack their beta cells that produce the insulin. It's not in everyone. It's one of the things they've seen that can lead to the immune response. Others, it just naturally happens, or they have no idea what triggered the body to then attack those cells.
Mhm. Have you read anything lately with the COVID so rampant? You know, are they detecting any gravitation to like the pancreas and
So there's been really small studies and case studies on it where there have been some people they've seen where the virus actually
Oh, Rachel, we're losing your internet connection.
doesn't when the immune response happens. So there's been some cases where people have gotten it and then they test and they don't have any of the antibodies indicative of type 1, but their insulin producing cells have been destroyed. But again, that was a study that had maybe one person or two people, like case studies that were describing that. But that's one thing they're looking out for in the coming months and years, I guess, after this, to see really if there is an increase in diagnosis after.
Jerry, did you have another question?
Just, if you have type 1 diabetes, would you, if you hadn't taken care of it or weren't taking care of it, would you move into type 2, or is it completely two different diseases, so to speak?
It's completely two different diseases.
Okay.
So type 2 is more focused on, there's multiple types of type 2 diabetes if you want to get into super specifics on that, but essentially type 2 is more an insulin resistant problem. So your body still produces insulin, but your cells become more and more resistant. So they can't use the insulin you're producing properly. Whereas in type 1, you just don't produce insulin. But as a type 1, you can become resistant to insulin due to stress, weight, sleep issues, different things. So
I think Donna had a question.
Yeah, I have a question. Rachel, if you have, if someone has one autoimmune disease,
Mhm.
are they more likely to find themselves with diabetes someday? Is there a link between, if you have one, it's easier to get another one? I mean, I know there are.
I think there's a link. Just if you have an autoimmune, it's likely you will start having multiple autoimmune diseases. I'm not sure if type 1 is more prevalent in that sense of it shows up more, but I know that it is known that a lot of people with type 1 tend to start developing other autoimmune diseases with it. But I'm not sure if type 1 diabetes is more common to show up if you have another autoimmune, or if it just happens to show up because it's common for, if you have one autoimmune disease, you start having multiple autoimmune diseases.
Interesting. I have one other question, and it has to do with these little gadgets that you implant. And, and I'm sure we don't all become bionic women or people if you do that, but is there discomfort that comes with, I'm intrigued by the fact that you can implant something under the skin and yet you see it outside the skin, and it seems to work the magic that you want it to work. And is that, for those individuals that have to experience that, is it something reasonable for them to deal with? Does it affect their daily lives, in terms of having that?
So, can you see it?
Oh,
Yeah.
It's relatively small and kind of thin. And the part that sits under the skin at this point is maybe a little bit thicker than a human hair.
wow.
So it's not a lot. It's inserted with the needle and then removed, and it's about maybe a 1/4 inch long that sits under the skin. I keep saying blood glucose, but it's actually measuring the glucose level that's in the interstitial fluid. So it doesn't have to go deep under the skin to get blood sugar readings. So they're relatively painless.
And do they run on batteries? And if so, how long do they last? And I'm assuming it must be safe. to have a battery that close or in your skin. But
Yeah, so the part that sits on the outside of the skin is what will have the batteries, and they're just tiny watch batteries. And so the transmitters, depending on the company that makes them, both of these are rechargeable. Whereas this one, you get a new transmitter every 3 months.
Oh, interesting. Interesting.
Whereas the sensor you change much more frequently.
And do these have to go through the same kind of long testing process? You know, we hear so much about viruses now and everything else, and it takes like 15 years to, you know, get the right answer that you can be assured of. You know, does the physical technology, the mechanical technology go through the same kind of research and protocol and things before it's approved for use?
Yeah, so they're all through FDA and approved. And recently the FDA has been working a lot since kind of they're coming out with more automated delivery systems. They've been kind of adjusting the guidelines on how they've been approving these systems and making it so the technology can come out faster. Since it's all been proven to be effective in the past, they're making it easier for these new sensors to come out a little bit quicker. Same with the pump technology and the algorithms as well, because it used to be the pump and algorithm had to be approved together, which would take longer, but now an algorithm can be approved separate from the insulin pump being approved by the FDA. So they've been tweaking their guidelines to kind of have some of these things be approved separately and faster, so people can get using the technology quicker.
Interesting. I have one last question for you, and then I promise I'm done. Can you see Kate smiling? She's going, thank God, she's just going to concentrate.
No, these are great questions.
But my question is, you know, it's wonderful work that you're doing, and where do you want to go with this in the future? I mean, and I'm not asking you to firmly commit to doing one thing or another, but, you know, do you have a plan that will enable you to benefit from all this good work you're doing?
Yeah, so any of this can be kind of taken to any of these pump or continuous glucose monitoring companies, because they're all competing against each other to have the next best automated system out for people. But also I'm looking into kind of some of the companies that are more creating these data viewing platforms for people, and maybe kind of developing tools for the people who don't have access to some of these insulin pumps, to still be able to learn how these things think and kind of do the control on themselves, even if they might not have access to some of these fancier insulin pumps.
Yeah, wow, wonderful work ahead, whatever you choose, whatever path you take. Thank you.
Thank you.
Okay, I have just a few more questions. So we started these virtual seminars, if you will, I think around April or May. And so of course, COVID is very, you know, top of mind. And you know, it's been interesting kind of hearing from the scholars and how the work has been impacted. So I'd love to hear from you about, you know, how your work was impacted during, you know, April and May, and then, you know, how Illinois Tech has been adjusting since then.
Yeah, so a lot of our work was done kind of in collaboration with UIC and University of Chicago. We never actually ran the in-person experiments because we don't have a medical school associated with IIT. And so UIC, all of our experiments at UIC had to be stopped in March. But we were relatively done with a lot of our in-person experiments we had planned. So all the data collection that people were doing at home continued. So we were able to get some more from about 4 more participants during this time. And the rest of our stuff is just on the computer. So we didn't have a huge struggle in transitioning. The biggest issue was, since we are such kind of a collaborative group, everyone kind of going separate and not being able to just talk to whoever you need to in the lab that day. That was more of the adjustment. and kind of figuring out how you can stay in communication and get your your questions answered relatively quickly. That was more of the adjustment, and most of us are still staying at home from the lab. The only people who have been going back and forth are those who live within walking distance. Our advisor even is just telling us, if you have a nice setup at home, stay home. We have no idea what's going to happen once the school opens. And IIT has all of their classes remote for the next 2 weeks before they decide what's going to happen there. And almost every class has a remote option. So I'm sure the kind of student population at IIT will be reduced no matter what. So we weren't hugely impacted by having to stay home, which was nice, but it was more kind of the collaboration dropped a little bit.
Yeah, one that echoes, I think, what we've already heard is, that fortunately we all have computers and can do a ton of work. And we've heard of some examples of people who had wet lab work and transitioned to, computational experiments. But yeah, it's true. There's, while we love the Zoom, there's no replacement for in-person connections. I have, I think one last question, and then I think we can see if there's any other last questions within this. So have you been a subject in your own study?
Not in my own study. I've been subjects for other people in the lab. I've tested out our algorithms in the lab for people because they wanted to test some minor tweaks but didn't want to set up a full experiment. So I've used our system in the lab, but I haven't been a patient in my own research for this stuff. I've definitely tested out all the devices to get ideas for how the experiments should be run and what's most comfortable for people. And I think that's a little beneficial, just so you kind of get a sense of what you're asking your research subjects to do. But yeah, nothing specific in my own research.
Cool. It's true. I imagine you probably have insights that no one else will have. That's very cool. Are there other questions from the team?
Oh, wonderful presentation.
Yeah. Thank you so much, Rachel. This has been really interesting. We all really appreciate it.
Thank you so much.
Very
Thank
good.
you.
Very nice. And
Yes,
good luck
thank you so much.
going forward. Thank you.
And thank you, Patty, for putting it together.
Okay. Thank you.
Yes, indeed.
Yes, always happy to have us host on a Zoom. So thanks very much, everybody. We will see you next time. Take care.
Great.
Thank
Thanks.
you.
Thanks so much,
Bye-bye.
everyone. Bye.
Bye.